Let's continue our journey where data not only speaks, but draws beautiful patterns on graphs. Today's question says, a dataset represents the distribution of prediction confidence scores generated by a machine learning classification model across multiple test samples. The grouped frequency distribution of confidence scores is given below. Score range 80 to 89, 90 to 99, 100 to 109, 110 to 119, 120 to 129, 130 to 139, 140 to 1149. Frequency 8, 16, 20, 26, 50, 13, 5. We have to draw the frequency polygon, construct the less than ogive, construct the more than ogive, and find the median graphically. Also, we need to justify the answer. Now imagine this. An AI model is predicting how confident it is about its answers. Some predictions are low confidence, some are high. If we arrange all these scores, the median will tell us the middle confidence level of the model. That's like finding the balance point of performance. Let us begin step by step. First, we convert the inclusive series into a continuous series. The formula is class boundary correction equals difference between upper limit and next lower limit divided by 2. Here, the difference between 90 and 89 is 1. So correction factor equals 1 divided by 2, that is 0.5. So we subtract 0.5 from each lower limit and add 0.5 to each upper limit. Now the continuous class boundaries become 79.5 to 89.5 with frequency 8, 89.5 to 99.5 with frequency 16, 99.5 to 109.5 with frequency 20, 109.5 to 190.5 with frequency 26, 195 to 129.5 with frequency 50, 129.5 to 139.5 with frequency 13, 39.5 to 149.5 with frequency 5. Now let us find the total frequency. Total frequency n equals 8 plus 16 plus 20 plus 26 plus 50 plus 13 plus 5. So n equals 138. Next we find midpoints for the frequency polygon. The formula is midpoint equals open bracket lower boundary plus upper boundary close bracket divided by 2. So the midpoints are 84.5, 94.5, 104.5, 114.5, 124.5, 134.5, and 144.5. Now imagine plotting these points. Image, we draw two perpendicular axes. On the x-axis, we mark midpoints. On the y-axis, we mark frequency. Now we plot the points. 84.5, 88, 94.5, 16, 104.5, 20, 114.5, 26, 124.5, 50, 134.5, 13, 144.5, 5. Then we join all these points using straight lines. To close the polygon, we add two imaginary points, 74.5, 0 and 154.5, 0. This forms a complete frequency polygon. Now let us move towards ogives, which are cumulative frequency curves. First, we construct the less than cumulative frequency table. Let's read it carefully, like a teacher explaining a table. At upper boundary 89.5, cumulative frequency is 8, so point is 89.5, 8. At 99.5, cumulative frequency becomes 24, so point is 99.5, 24. At 109.5, cumulative frequency is 44. At 190.5, cumulative frequency is 70. At 129.5, cumulative frequency is 120. At 139.5, cumulative frequency is 133. At 149.5, cumulative frequency is 138. We also take one starting point, 79.5, 0. Now we join these points with a smooth increasing curve. This is the less than ogive. Now for the more than cumulative frequency. At lower boundary 79.5, cumulative frequency is 138. At 89.5, it becomes 130. At 99.5, it is 114. At 109.5, it is 94. At 109.5, it is 68. At 129.5, it is 18. At 139.5, it is 5. At 149.5, it is 0. Now plot these points and join them with a smooth decreasing curve. This is the more than ogive. Image, now comes the key idea, finding the median. The formula is median position equals n divided by 2. So median position equals 138 divided by 2, which is 69. Now locate 69 on the y-axis. From this point, draw a horizontal line parallel to the x-axis. This horizontal line will intersect both curves. From the point of intersection, drop a perpendicular line to the x-axis. The point where it touches the x-axis gives the median. From the graph, this value comes approximately equal to 119. So we say Median equals approximately 119. Now let us justify this result logically. We know that median lies at position n by 2, which is 69. Now look at cumulative frequencies. The value just greater than 69 is 70, and this corresponds to the class 109.5 to 109.5, so the median must lie inside this class. This matches perfectly with the graphical result we obtained. So both analytical thinking and graphical method agree, and that gives us confidence in our answer. So finally, we conclude that the median prediction confidence score of the machine learning model is approximately 119. This means half of the predictions have confidence less than 119, and half have more than 119. A beautiful balance point in the data, Isan. Keep practicing these graphs, because once you master them, data will stop being numbers and start becoming stories you can see and understand.